Okay, this time it says Ava wants to solve 5x squared plus 9x plus 3 equals 0 by completing the square. Here is her first step. Discuss with the classmate, what did Alma do? So the first thing that she did is she divided every one thing by 5 to get it into a form that she can complete the square of, because she wanted to get the a to be 1. Why do you think this was her first step? So that she could complete the square, because in order to complete the square, we do need the a value to be 1. What would you do next? So the next thing we would do would be to take 9/5, which is b, divided by 2 and square it. Okay? So then on the next slide, that's what we're doing. We're describing each step. So the first step was the original equation, and then we divided everything by 5. Now she has subtracted 3/5 from both sides. And then we see her next step. In her next step, she divided 9/5 by 2, because we do b divided by 2, squared it, and added it to both sides. So she divided, that's how she got times 2, because dividing by 2 is the same as multiplying 1 by 1/2. She divided 9/5 by 2 and squared it, and then added it to both sides. So that's where she got the 9/5 times the 2, okay? Because 9/5 divided by 2 is the same as 9/5 times 2, times 1/2. Okay, next step. She factored the perfect square. So she factored the x squared, this part of the equation, to be x plus 9/10 squared. Because 9/10 is what you get when you multiply 9/5 by 1/2. Then she square rooted both sides. And then she subtracted 9/10 from both sides. Finally, she rewrote it. And if you notice, it's rewritten in the quadratic. So if she simplified what was underneath it and then made it over 10, and then we simplified it, all of that, to get the 2 times 5. So the 2 times 5 is just the 10. All right. So then it says more equations. So basically what we're doing is if we change our a, b, and c in our equation, we notice that in the quadratic that it changes in different spots. So like the 3, if I change it to a 3, it became an opposite of 3 and 3 squared. If I change this to a 1, it becomes 1 squared and the opposite of 1. If I change c to -2, I'm multiplying by -2. So when I change it in here, it's changing in the quadratic equation. Okay, so it says, Philippe notices that you can write the solution to an equation without completing the square. How would the solution change if the original equation were 3x squared plus 8x minus 15? So it would become x, I'm trying to type it in, x equals the opposite of 8, okay? And then I'm going to try to do this plus so I'm going to do plus, minus, like that, the square root of 8 squared minus 4 times 3 times -15 divided by 2 times 3. And I'm going to move this negative sign. So that's how we would show where the numbers change. And again, we're just typing them into the quadratic formula. Okay, so then it says, where would our values go? So we know that B goes here and here. We know that it's times A and C, and then it's eventually times 2A. And then click check your work. All right, so it says the equation is known as the quadratic formula. So what do the A, B, and C in the formula represent? They're the numbers in front of x squared, so A is in front of x squared, B is in front of x, and C is the constant. Why is there a plus or minus? Because whenever I square root anything, it's always the positive and the negative version. And what new things could this formula help us do? So it helps us solve a quadratic when we can't factor it. So if I can't factor the form, it's unfactorable. The quadratic formula is another way, especially if the answer is a decimal or a fraction. All right, so this one we needed a supplement for, and I'll give you the supplement when you return to school. But basically you had to come up with ways for it to be no solution, only one solution, and two integer solutions. So we know if we make it, like, for example, if I make it a perfect square. So I make it -2. So -2 divided by 2 is -1. -1 squared is 1. So if I change this to be a perfect square, it's going to give me an answer where it's only one solution. Okay, but then if I change this to a 4, there are no solutions. Okay, if I change this to a +2, there are no solutions again. So I had to come up with ways where there was two solutions that were integers, one solution, which is when it's a perfect square, and then when there's no solution. Okay, so a classmate who's absent today asks you for help. What would you say to them? Understand? So you can substitute the values A, B, and C into the quadratic formula and find the answers for X. Okay, and then the cool down says Santino and Luca used two different strategies to solve x squared plus 14x plus 24. Santino solved by completing the square, and Luca used the quadratic. So explain why the solutions are equivalent. They're the same thing, but Luca's is divided by 2. Or no, Santino's. Hope this video helps.